Okay, continuing on with section 2.5 homework. Problem number 2 says find any x-intercepts, vertical asymptotes, undefined points, horizontal asymptotes, and oblique asymptotes for the following equations. Problem A, f of x equals 9x squared minus 4 over 6x squared minus 22x plus 12. We can type these equations right into the rational sheet. I have the rational sheet open, and you can put in your coefficients for your numerator, which are 9, 0, and negative 4, starting with the B1, and your coefficients for the denominator, which are 6, negative 22, and 12. And then your horizontal asymptote automatically shows up here. Click this button to get your undefined points, x-intercepts, and vertical asymptotes. So we see that there's an x-intercept at negative 0.667, and there's a vertical asymptote at 3, and there's an undefined point at 0.667, which is the same as 2/3. The x-intercept's at negative 0.667, which is the same as negative 2/3, and then you get the y value of the undefined point on the right here of negative 0.857. And again, here's the horizontal asymptote, and if it has a horizontal asymptote, then it does not have an oblique asymptote, so there's no oblique asymptote. So now, doing that same problem by hand, you'd have to factor this expression, and to factor it, if you have trouble with that, you can use the poly sheet and do one bit at a time. Over here on the poly sheet, like for example, here's the 6x squared minus 22x plus 12 factored, and you would do the same thing with the 9x squared minus 4, put that in and it will factor it, or you can do it by hand, trial and error, or however you like to factor. Then once you have these things factored, then a 3x minus 2 is common to the numerator and denominator, so that cancels out, and you're just left with this. Now the x-intercept is where the numerator is equal to 0. So if you said 3x plus 2 equal to 0 and solve it, you take the 2 to the other side and divide by 3, you get negative 2/3. Vertical asymptote is where the denominator equals 0, so set x minus 3 equal to 0 and you get x equals 3. The undefined point comes from the term that was completely canceled out, which is the 3x minus 2. Set the 3x minus 2 equal to 0 and you get x equals 2/3, or 0.667. To get the y part of your undefined point, you have to substitute the 2/3 back into the simplified expression. So you'd have to take 3 times 2/3 plus 2, and that's done right here, over 2 times 2/3 minus 3. And if you work that out, you'll get your negative 0.857. So that's the total undefined point. That would be the hole in the graph here. The horizontal asymptote, look at your powers of your numerator and denominator. The power of the numerator is the simplified one is to the first power. The power of the denominator is to the first power. And when the powers are the same, look at the leading coefficients. The leading coefficient of this is 3. The leading coefficient of this is 2. 3 over 2, or 1.5. Part B, it just flips it and raises the power of the one thing. So on the top here, instead of being 9x squared minus 4, it's 9x cubed minus 4x. An x factors out of that, and you're back to 9x squared minus 4, which factors into 3x plus 2, 3x minus 2. The bottom, we've already factored that. The 3x minus 2 cancels out, so that's going to give you the same x part of the undefined point we had before of 2/3. X-intercept is where you have set, after you simplify it, set the numerator equals 0, and you'll get where x equals 0, and also where also right here, set this equal to 0, and you get negative 2/3. So there's actually two x-intercepts, one at negative 2/3, and the other one at actually 0, 0. And that 0 came from setting each term right here equal to 0. Okay. Now vertical asymptote, set the denominator equals 0, and you get x equals 3. The undefined point, same one as before, 2/3, and then just substitute the 2/3 into the simplified expression to get the y part of the undefined point. It does not have a horizontal asymptote. The reason it doesn't is because the power of the numerator, even if you look at it here, the power of the numerator is 3, power of the denominator is 2. The power of the numerator is bigger than the denominator. That does not have a horizontal asymptote. This one here, if you multiply the x through, it would be x squared. On the bottom, it's x. So again, the numerator power is bigger than the denominator. Whenever that happens, you do not, then there is no horizontal asymptote, which means as x is approaching infinity, the y is also approaching infinity. It does not level off. It just keeps going up or keeps going down. Okay, problem C. You have two expressions, factor them, and you get this. The 3x minus 2 cancels. You still have a leftover 3x minus 2 on the top, so and a 5x plus 4 on the bottom. It looks like the x-intercept would be where you set 3x minus 2 equal to 0 and solve it. So it looks like there would be 1 at 2/3. But in fact, that 3x minus 2 also canceled out. And when you have a term that cancels out, even if it doesn't completely cancel out, it's either going to be an undefined point or a vertical asymptote. So it definitely cannot be an x-intercept. It would only be a vertical asymptote if it was left over in the bottom. So since it's not left over in the bottom, and it can't be an x-intercept because we canceled the 3x minus 2 out, at least one on the top and bottom, then that 3x minus 2, the value that makes 3x minus 2 equal 0 is not an x-intercept, it's actually an undefined point. The value that makes 3x minus 2 equal to 0 is 2/3. Just set 3x minus 2 equals 0, you get 2/3. So 2/3 is actually the undefined point, not an x-intercept. And since there's no other term up here, there is no x-intercept. To get the y part of the vertex point, just substitute the 2/3 back into the simplified expression and you'll get 0. So that means there's an undefined point at 0.667, in other words 2/3, comma 0. To get the vertical asymptote, set the denominator equal to 0. If you set 5x plus 4 equals 0, you get negative 4/5 or negative 0.8. And the horizontal asymptote, look at the powers. The powers are the same. So if the powers are the same, look at the leading coefficient. Well, that's 9 over 15. That actually reduces down to 3/5, so that would be the horizontal asymptote at y equals 3/5. And we get the same thing here looking at the simplified version, 3 over 5. So since there's a horizontal asymptote, there's no oblique asymptote. And again, you can do this problem right off the bat on the rational sheet, just putting in your values, going down here, 9, negative 12, and 4, and then over here putting in the 15, 2, and minus 8. And when you do that, here's your horizontal asymptote automatically calculated at 0.6 or 3/5, same as what we had right there. Click on this to get most of everything else here. Undefined point at 0.667. That's what we said the undefined point was. What is the y part of the undefined point? 0, like we said. X-intercept. No x-intercept listed, so there's no x-intercept. How about vertical asymptote at negative 0.8 right here? So there's that one. Here in problem D, it's just the flip of problem C. So it factors, and then at this point a 3x minus 2 cancels out top and bottom, but you have a 3x minus 2 left over on the bottom. And that's the main point with this particular problem, is that there's a 3x minus 2 left over on the bottom, compared with the last problem in which there was a 3x minus 2 left over on the top. Well, when you cancel a term out, top and bottom, even if there's a leftover term, it can only be one of two things. It's either an undefined point or a vertical asymptote. It can only be a vertical asymptote if the leftover term is in the bottom, and that's where this leftover term is, in the bottom. So the value that makes 3x minus 2 equal to 0 is going to be a vertical asymptote this time. Up here, see, the 3x minus 2 was on the top. It cannot be an x-intercept if you canceled a term out. So it had to be an undefined point. And if you cancel it out completely, it's definitely an undefined point. But if it's left over in the bottom, it's a vertical asymptote. So just set the 3x minus 2 equal to 0. If you do that, you get 2/3, and that's where there's a vertical asymptote right there at 2/3. The x-intercept is going to be where 5x plus 4 is equal to 0, or negative 4/5, and the horizontal asymptote's at 5/3. Powers are the same. That's why you look at the leading coefficient. So I think that's everything with that particular problem. On this one, x-intercept, just set the numerator equal to 0, you get negative 3/2. Vertical asymptote, set the denominator, you get negative 2/5. There's no undefined point, nothing canceled out. And there's also no horizontal asymptote, because when you look at the power of the numerator is bigger than the power of the denominator. When that happens, then there's no horizontal asymptote. And to find, and also when that happens, that there's no horizontal asymptote, there could be an oblique asymptote if the power of the numerator is 1 bigger than the power of the denominator. That happened on this one. Now, what would be the oblique asymptote? Well, what you'd have to do is take the 2x plus 3 and cube it, and then the 5x plus 2 and square it using the poly sheet, and then put the coefficients for that into the rational sheet, and then you would get your location of your oblique asymptote right down here in this area. Problem F is this one, 3x plus 2 minus 5x to the negative 1. Well, x to the negative 1 is going to get flipped to the bottom. The 5 doesn't. It's only the x that's raised to the negative exponent. So I wrote all these with denominators. The 3x is the same as 3x over 1. The 2 is the same as 2 over 1. And this is minus 5 over x. Now get a common denominator. Now the common denominator is x, so I'll have to multiply the 3x top and bottom by x over x. Same way with the 2. I have to multiply it top and bottom by x over x, and the 5 is already over x. So now that I got a common denominator, my top is 3xx, or in other words 3x squared, plus 2x minus 5. This thing right here factors into 3x plus 5x minus 1, and now you're ready to go. Nothing cancels out, so there's no undefined point. Just set the numerator equal to 0. That's where the 3x plus 5 equals 0, so you'll get negative 5/3 from this one, and you'll get 1 from this one. So those are your two x-intercepts. Vertical asymptotes where the denominator equals 0, so that's at x equals 0. No undefined point. And also, in terms of horizontal asymptotes, look at the powers. And it's easiest to do this when it's simplified like this, or right here would be the easiest place. You can't really look at it up here till you have it simplified. And on this, the powers of the numerator is 2, power of the denominator is 1. And when this power, top, is bigger than the denominator, then it does not have a horizontal asymptote. If this is 1 bigger than this, which it is, it has an oblique asymptote. So this one you can actually put into Excel the coefficients 3, 2, negative 5, and I'll do that. So putting those coefficients into Excel, you can click here and get your x-intercepts. You see no horizontal asymptote, but if you scroll down, you'll see that the oblique asymptote is right here. This is the slope, 3, and this is the y-intercept, 2. So the equation of the oblique asymptote is y equals 3x plus 2. It's still heading off to infinity, but it's heading off in a straight line. And this one you can also see that there's a vertical asymptote, an oblique asymptote, by realizing as x approaches infinity, this bit right here, the 5 over x, will get smaller and smaller. If you put in large numbers for x, 5 over a very large number is a very small number. So this bit right here approaches 0. So all you're left with as you approach infinity is just the 3x plus 2. So the graph gets closer and closer to just an oblique line as you go farther with this graph. And we'll take a quick look at this graph. So see, it just looks like a straight line in the long run, but if we look close, then it looks something like this. And here, because there's vertical asymptote and there could be x-intercepts and so on, but really in the long run, let's just go negative 10 to 10, and you can see that it starts to get more linear as you go farther and farther out. This asymptote stuff is only happening in this area, and then it looks more linear as you go. Let's go negative 30 to 30, and you can see that here's your little blip where your asymptote is. It actually goes to infinity right there on both sides. There's an x-intercept here and an x-intercept there, and that's the look at that graph.